All right, guys, so today we're going to start talking about our first learning goal in our second unit. I am on page 31 and we'll be doing page 32 in your book. This is just a little introduction into angle relationships. So I don't want this to be a super long video, so I've got up a version that already has a bunch of the notes already filled in for you. I'm just going to go ahead and explain those. Um, Anytime that you need to pause the video so that you can copy down everything that's on the screen into your book, please do that. That way you can actually hear what I'm saying instead of trying to focus on hurrying up and copying down, what's on the screen without really listening. Okay. So first, just a couple symbols here. All of these symbols you'll see in this unit. We've got the very first one there, which is a right angle. It just looks like the letter L, really, right? More often, that L will be turned so it won't look quite like an L. Like, for example, when I have a triangle, sometimes to show that that is a right angle in a triangle, we'll put that little symbol there, okay? So we know that that's a right angle. The next one is just showing us that two lines are perpendicular. So actually, what are we doing here? Well, let's erase the word angle. That's just showing that two lines are perpendicular, meaning that the two lines will meet at a 90-degree angle. The next symbol, we've actually talked about this word a lot from the first unit, or from the first learning goal, but it is congruent. Remember, that means the same as or equal to. For the next one, it's this symbol here, what they're talking about, okay? And that represents the word angle. So, if I had a triangle, let's say I had a triangle, we'll call this triangle ABC, okay? And let me zoom in even further, and let's say that this one is 50 degrees. This one is 50 degrees, which would leave 80 degrees for this one. Okay, if they were to write out a question using that angle symbol, let's say angle B equals, you just need to put down what the measurement for angle B is. Okay, when we're referring to the different angles, we'll just put that angle symbol there in front of either the letter of the vertex or the vertice, or we will have a number sometimes. All right. For the next one, when there's an M in front of it, it should be measurement of angle. And yeah, I know my example up above doesn't fit that, so let's go ahead and put that M in front. So that's a good example for that one. But when you see an M in front, they're just asking for the measurement. And then finally, this one that just looks like two lines side by side, almost looks like two L's. It just means that two lines are parallel. So an easy way to remember that is when you look at the word parallel and then you see these two symbols, you can see, I'll use a different color so this sticks out a little bit better, but you can see it just looks like the middle of the word parallel, right? So we could say, if I've got two lines, line A and line B, and they were parallel, I could use that symbol to show that A is parallel to B. That's all, okay? All right, now that we know some of the symbols, let's go over a bunch of these angle relationships that we're using here, okay? We have complementary angles, which you may remember. This one might be familiar, and it's just two angles that sum to 90 degrees. So those two angles will add up to 90 degrees. For instance, in my example here, you can see I have angle A and angle B that would add up to 90 degrees. We call those complementary. We would say angle A and angle B are complementary angles. The next one is supplementary. Supplementary angles are two angles that sum to 180 degrees. So you can see in the example here, we know that in any line, it's 180 degrees. So if I have that line being intersected by another line, the angles that get formed from that are going to be supplementary. They will add up to 180 degrees. So we would say in this example, angles A and B are supplementary because we know that they sum or add up to 180 degrees. All right, a linear pair is two angles that create a straight line. We also know that if they're going to create a straight line, based off what I just said for supplementary, that they're going to add up to 180 degrees. That would mean that they are also supplementary. So there's an example of that. Vertical angles. Vertical angles are two angles across from each other when two lines intersect. Okay, and what we mean by across from each other is when I look at my example here, the vertical angles, the vertical angles are A and B. Those two are vertical angles. They're across from one another. They're not side by side. Okay, angle E, I'll use a different color here, but angle E and angle X are also vertical angles because they are not side by side, they are across from each other. Okay, so vertical angles come from when two lines intersect or more. We'll talk about that later, but they are across from each other, directly across from each other. They do not share any sides. Okay, one important thing to remember with that is that they are equal in measure. So those two angles are going to have the same amount. If I tell you, based off of this example, that angle A is 40 degrees, you already know what angle B measures. It's also 40 degrees because those two angles are vertical angles, and vertical angles are equal in measure. Okay? And then finally, I have adjacent angles, and those are angles that share a side. Okay, so they're going to have a common vertex and a common side. And that's why I added that word and vertex. Angles that share a side and a vertex are adjacent angles. In this instance, you can see here we have angle A and angle B side by side. They share that same vertex there. They are adjacent angles. Okay. All right. On the next page, so on page 32, again, if you need to pause the video because all of this is already written out, go ahead and do that. All right. And I'm going to erase this. Okay. I've got two theorems here that have to do with triangles that we're going to talk about here. The first one is the triangle angle sum theorem, and that is just that the sum of the interior angles of any triangle is 180 degrees. It doesn't matter what the triangle looks like. When you add together the three angles on the inside, that's where that word sum comes from, right? When I'm adding together those three angles on the inside, it's going to equal 180 degrees. So you can see over here to the side, I wrote what that would look like mathematically using our symbols from the other page. So I have angle A, B, and C. The measurement of angle A plus the measurement of angle B plus the measurement of angle C has to equal 180 degrees. And that is my, that is my triangle angle sum theorem. Now the exterior angle theorem says that the exterior angle you get to see my update come on your screen there too. Any exterior angle is equal to the sum of the two opposite not exterior, interior angles. Okay, so when I say exterior angle, I'm referring to the exterior angle of a triangle. So the exterior angle theorem has to do with triangles because these are all the properties of triangles, okay? But using the example from up above, let's redraw that triangle. So I've got angle A, angle B, and angle C. If I were to extend one of the sides of that triangle, doesn't matter which one, okay? This works for any of them. So if I were to extend one of the sides of the triangle, I'll do line AC there, okay? This exterior angle, let's say that this exterior angle here is angle E, okay? The measurement of angle E is equal to the two opposite interior angles added together. Because remember, that's what that word sum means. So the two opposite interior angles, so it's not C. C is the adjacent angle. I want the two opposite angles. So it would be A and B. It's equal to the measurement of angle A plus the measurement of angle B. Okay, those two things are equal. That exterior angle is always going to equal the two opposite interior angles added together. Okay. All right, so next we're going to talk about transversals, and just a quick reminder that a transversal is a line that intersects two parallel lines. Okay, so I've got a little drawing here. The purple line is our transversal. Okay, the two yellow/orange lines are the parallel lines. The purple one is the transversal. And what happens is these special relationships get formed. So when a transversal or a line cuts through two parallel lines, it forms these 8 angles. Okay, sometimes there can be more angles formed if there's more lines. But what we're going to focus on for right now is just when two parallel lines get crossed by a transversal. Okay, and a transversal, that's what we call the line that cuts through those two parallel lines. For my corresponding angles, so I'll zoom out so we can see this a little bit better. My corresponding angles are angles that are in the same position, the same relative position. Okay, and then in parentheses I have that they are congruent. Remember, congruent means the same as or equal to. Okay, so when I zoom in on my drawing, when I zoom in on my example here, the corresponding angles are in the same position. So what do I mean by that? Well, let's cover up this bottom half real quick. Let's make it let's orange it out so we can't even see it. All right, now when you look at this, when you just focus on this intersection here, we could describe each one of those angles as being in a specific position. So for instance, angle 1 we could say is in the upper left position. Angle 2 is in the upper right position. Angle 3 is in the bottom left position, and angle 4 is in the bottom right position, right? Well, if I cover up those angles and only focus on the bottom ones, we could do the same thing. For the bottom intersection, we could say which one was in the upper left position, the upper right, the lower left, and the lower right. And the way that that's going to show us the corresponding angles is we see which ones are in the same position just at the different intersections. So for instance, let's undo all my scribbly marks here. Angle 1 and angle A are in the same relative position. Okay, again, if I were to cover up that bottom intersection, angle A was in the upper left position, angle 1 is in the upper left position. And you can see how they look like they would be congruent. They both are obtuse angles. That's what tells us that they are in that same relative position. Angle 2 and angle B are corresponding angles. Angle 3 and angle C are corresponding angles. And angle 4 and angle D are corresponding angles. So the way that I'm going to write that out off to the side here so that we don't forget it is angle 1 and angle A, angle 2 and angle B, angle 3 and angle C, and angle 4 and angle D. Those are my corresponding angles. Okay, and they are congruent. So if I were to tell you that angle 1 is 110 degrees, you would also know that angle A is 110 degrees. Okay. For alternate interior angles are just two interior angles that are on different parallel lines on opposite sides of the transversal. So when I zoom in on my little drawing here, they are inside the parallel lines. That's where the word interior comes from. Angle A and angle C are at the same intersection. So when we talk about alternate interior angles, we're talking about angles that are at opposite intersections. Okay, so A and C cannot be alternate interior angles. It would be angle A and angle B. Because look, angle A is on the left side of the transversal, angle B is on the right side of the transversal, and they're at opposite parallel lines. They're at different parallel lines. Okay, they're both inside the parallel lines, they're on opposite sides of the transversal, and they're at opposite parallel lines. They're at the different parallel lines. So I'll put off to the side here, whoops. I'll put off to the side here angle A and angle B are alternate interior angles. Angle C and angle D are also alternate interior angles because they are also inside the parallel lines, in between the parallel lines, and they're on opposite sides of the transversal. They're also at opposite intersections. Okay, and one important thing to note here is that I wrote it for corresponding angles. They are congruent. Alternate interior angles, those are also congruent, which means they are equal to each other. Okay, if I tell you angle A is 60 degrees, then you know angle B is also 60 degrees. Okay. Alternate exterior angles sounds just like alternate interior angles, and that's because it's the same thing, except now instead of being inside the parallel lines, they're outside the parallel lines. Okay, so they're not in between the two parallel lines, they're on the outside of the two parallel lines. Again, that would be angle A and angle B. Those are alternate exterior angles. Angle C and angle D are also alternate exterior angles. Okay. Look, if you take a look at that, they look like the same. Angle A and angle B there both look like they're the same measurement. And you guessed it, we're going to write congruent there for that also. All right, only a few left here. For consecutive interior angles, that's when you're looking, there's that word interior, you're looking in between the two parallel lines, but instead of being on opposite sides of the transversal, they're on the same side as the transversal. So that's what that two interior angles on the same side of the transversal comes from. Those are not congruent. Those are not congruent, okay? However, they will add up to 180 degrees, okay? They will add up to 180 degrees. Vertical angles we've already talked about. I just showed you some examples. I didn't write down the definition again. We don't need to do that. But I did show you some examples here. A and B are vertical angles. They're across from each other. They don't share a common side, right? But they are vertical angles. They're congruent. Angle C and angle D, those are both vertical angles because they have that common vertex and they're opposite or across from each other. And then the last one here, adjacent angles, we already covered. I didn't put the definition or do an example, but just so you can see an example really quick, if I were to draw two parallel lines, and let's cross it with a red line. Adjacent angles are just angles that share a common vertex and a common side. So here's a point, here's a point. Let's say that this is angle A and this is angle B. And let's say that this is angle C and angle D down here. Angle A and angle B are adjacent angles. They share a common vertex and a common side. Angle A and angle D are not. They're still on opposite sides of the transversal, but angle A and angle D, those are not adjacent. They're not side by side. Okay. Angle C and angle D, those would be adjacent angles. All right, so what you're going to do next is just go ahead and try and answer as many questions you can on pages, I'll make sure I say the right page numbers here, 33 and 34. Refer back to these notes, just see if you can identify these different types of relationships that we went over in the notes here. All right, make sure you ask your teacher if you have any questions.